Hello everyone. Today we are going to estimate the value of pi using a simple yet fascinating technique called the Monte Carlo method. Let's get started. First imagine that we have a square of side length 1. So as you can see, this is a square of side length 1, and inside that square let's try to create a circle that perfectly inscribed it, uh, and the radius of this particular circle is 0.5 unit and the diameter is 1 unit. Now what we will do, let's try to sample some random points which are uniformly distributed on this particular square only. So let me draw some random point on the square itself. As you can see, we have like these number of points. Some of the points are lying inside the circle, which are in green color, and the some of the points are lying outside the circle, which are in red color. So here is the key idea. The ratio of the number of points that are lying inside the circle to that of the total number of points will be proportional to the ratio of the area of the circle to the area of the square basically. Let's see how can we estimate the value of pi using this assumption. So the area of circle will be equal to pi r square, which will be equal to pi into 0.5 square, and which will be equal to pi by 4, right? And the area of square for our case would be 1 into 1, that is equal to 1. So what we are saying, the ratio of the area of circle to the area of square will be proportional to the number of points that are lying on the circle with respect to the total point, or the number of points lying on the square. So let's say n total, right? So this a circle upon a square will become pi by 4. This will be equal to this quantity, like n circle divided by n total, or we can also say pi is nearly equal to 4 times number of point lying on the circle divided by the total number of points, right? So for our estimation we will be using this formula to estimate the value of pi. So let's see how the code looks for this. So I have already prepared the code for this. Let's walk through the code. Let's assume we are starting with 1000 random points. So we will draw 1000 2D random points using the function np.random.random. So let me show like what is the output of this particular function. Let's say we wanted to draw only 4 points of 2 dimension within the where the x and y values are within the range of 0 and 1. So this will be the output. After that we will create the center of our circle. So as you can see, for this example, the center of our circle is 0.5, 0.5. Also, we will create a counter to find the number of points that are lying inside the circle, and the radius of our circle is 0.5. Now what we will do, we will iterate or loop through all the points, and for each point we will find its x coordinates and y coordinate. Similarly, we will find the center of circle, like the x and y coordinate, and we will find the distance between the center of circle and the point. And we know, like, if any point distance is less than radius, then it will be lying inside the circle, otherwise it will be lying outside the circle. So we are incrementing the counter for the points inside the circle if the distance is less than equal to radius basically. And at the end we will use the same formula to estimate the value of pi, that is 4 into number of circle, like number of points inside the circle divided by the total number of points. So if I run it, so we can see like it is estimating the value of pi. It is not very accurate, but it is close enough, right? So if we increase the number of points, let's say, maybe we will get more accurate results. So here you can say this is like slightly better than using just 100 or 1000 points. So the idea is the more random points you have, maybe your estimate would be more accurate. So like this is also the similar code. The only thing is I have added some of the visualization part for better understanding. So you can take screenshot of that part as well if you wanted to draw these circle, square, or everything. So that's it. Thanks for watching. See you in the next one.